We now discuss the sensitivity analysis of the right-hand side values. In the example of the blue ridge, we have the right-hand side values of 200 for the pumps constraint, 1,566 for the labor constraint, 2,880 for the tubing constraint. Suppose we focus on the labor constraints of the 1,566. In this case, we suppose Blue Ridge can ask the employees to work overtime, and we pay for them. One immediate question is, how much would Blue Ridge like to pay for each individual overtime hour? In other words, if we change the right-hand side value of 1,566 to 1,567, what will happen to the objective function value? In order to answer this question, we need to introduce a new concept called settle price. Settle price is a very useful concept. It indicates the marginal value of each individual resource. Formally, the settle price can be defined as the amount by which the objective function value change, given a unit of increase in the right-hand side value. Mathematically, we have settle price equal to change of the optimal value over the change of the right-hand side value. For example, we can increase the right-hand side value by 1, and we see how much will the optimal value change. In equation, we have settle price equal to new optimal value minus old optimal value over the new right-hand side value minus the old right-hand side value. If we manipulate this equation, we have the change of the optimal value equal to settle price times new right-hand side value minus the old right-hand side value. Of course, in order to use the equation, we must have the same settle price. In order to have the same settle price, we need to define another concept called range of feasibility. The range of feasibility is refers to the range of a specific right-hand side value in which we have the same binding constraints. When we have the same binding constraint, actually, we are going to have the same settle price. In other words, the settle price remains the same in the range of feasibility. Suppose we are in the range of feasibility. The maximum amount of the money that Blue Ridge would like to pay for each individual overtime actually will be equivalent to the settle price of the labor constraint. In that case, we have the settle price equal to the change of optimal value over the change of right-hand side. Suppose we increase the current right-hand side value of 1,566 to 1,567, and we have a new optimal value of 66,116.66 minus the old optimal value of 66,100. So we get 60. So we have the final value equal to 16.66. This is so the way we can use solver to resolve the entire problem by changing the right-hand side value to get the settle price. But of course, after we run the solver, we can get the sensitivity table for the range of feasibility and the settle price. In this table, we have the constraints as the title of this table. It refers to the range of feasibility table. Look at the three constraints. We have the pumps, the labor, and the tubing. We have current right-hand side value of 200, 1,566 for the labor, and 2,880 for the tubing. We also have the current left-hand side value of the final value to those three constraints. We have 200 for the pumps, 1,566 for the labor, and we have 2,712 for the tubing. As you can see, we have the first two values for the pump, 200, 200. They are the same. And for the labor, we have 1,566 for the left-hand side value and 1,566 for the right-hand side value. So it shows that the first two constraints are binding. But for the third constraint of Tillman, we have 2712 less than 2880. So this indicates that the Tillman constraint is not binding. In this case, we have long negative setup price for the first two constraints, and we have a zero setup price for the Tillman. It also indicates that if we have a setup price of zero, the constraint is not binding. Coming back to the allowable increase and allowable decrease. For the first constraint of the pumps, we have allowable increase of 7 and we have allowable decrease of 26. It means as long as we don't increase the right-hand side value by more than 7, we have the same setup price of 200. Similarly, for the labor, we have the allowable increase of 234, allowable decrease of 126. The combination of the allowable increase and the allowable decrease will be the range of feasibility. So in this case, for the pump, the range of feasibility is going to be the lower bound 200 minus 7, that would be 193, to the upper bound of the 200 plus 26, and that would be 226. So the range of feasibility for the pump's constraint will be from 193 to 226. So we have the allowable increase of 7 and allowable decrease of 26. Based on the sensitivity table of the range of feasibility, we can do some further computation. Suppose Blue Ridge is able to assign another 100 hours of the labor, and currently we want to suppose they are free. What would that change impact the total profit? And from the previous slides, we know that the change of the optimal value will be equal to the setup price times the right-hand side value change. Given that increase of 100 hours is within the allowable increase, so that we can use this equation directly to compute for the change of the optimal value, which will be equal to 16.66, the setup price of the labor constraint times 100 hours. So we get 1,666.66 for the change of the optimal value. Here I would like to comment further on the setup price and the change of the right-hand side value. Setup price holds only within the right-hand side value changes, falling within the value of the allowable increase and allowable decrease. In other words, setup price is the same within the range of feasibility. Setup price for the non-binding constraint are always zero. Setup price only indicates the change occur in the objective function value as right-hand side value change. And changing of a right-hand side value for a binding constraint also changing the feasible region and the optimal solution. In other words, if we change the right-hand side values, the feasible area will change and the optimal solution will change because the binding constraint moves. Thank you.